Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. In this video, we will look at wireless LAN configuration. In the past 3 videos, we covered a lot of theory about wireless networks. Finally, we'll get hands-on and see how to actually build a wireless LAN. We will cover exam topics 2.7, 2.8, and 2.9. 2.9 in particular tells us what we need to be able to configure for the CCNA exam. In addition, we will cover exam topic 5.10, which tells us we need to configure WLANs using WPA2 PSK, pre-shared key, using the GUI. Note that both topics 2.9 and 5.10 mention that we must use the GUI, Graphical User Interface. Up to this point in the course, we have only been using the CLI, Command Line Interface, to configure devices. You can configure wireless LANs via the CLI too, but it's much more common to use the GUI, and that's what Cisco expects you to know for the exam. Here's what we'll cover. First, I'll give an introduction to the network topology I'll be using for today's demonstration. Then I'll cover the necessary switch configurations, since we'll be connecting all devices to one central switch. Then I'll show the basic wireless LAN controller setup, so we will be able to access its GUI and do the configurations you need to know for the CCNA. Then I'll show how to configure the WLC's interfaces, and then we'll configure some wireless LANs. Finally, I'll take a look at some additional features on the WLC. There's a lot to explore in the WLC, and you only need to know the basics, so I'll just point out a few features you might want to be aware of. As always, watch until the end of the video for a bonus practice question from Boson Software's XSIM, the best practice exams for the CCNA. For the first time in this course, I will be using a physical lab. You can't make a wireless lab with virtual devices alone. With that said, a partially virtual lab is possible. I could have, for example, used a virtual WLC instead of a physical one, but I was able to get this hardware secondhand for a cheap price, so I decided to use all physical devices. Fortunately, you don't have to purchase physical hardware to practice wireless configuration for the CCNA. Packet Tracer does offer some basic WLC and AP functionality. It's limited, but it's good enough to practice what you need for the CCNA. Anyway, in this topology I have one switch, one wireless LAN controller, and 2 wireless APs. By the way, I haven't connected any power cables to the APs, but they are still receiving power. Can you guess how they are receiving power without a dedicated power cable? The answer is PoE, of course, Power over Ethernet. A single Ethernet cable is used to both pass data and provide power to the device. You can see here on the switch that its interfaces are PoE capable. Actually, the WLC itself also has 2 PoE capable ports, although I'm not using them in this lab. So an AP could be directly connected to the WLC itself and receive power via PoE. Here's the network topology. Note that the WLC connects to the switch via a LAG, link aggregation group. You might remember from my Ether channel video that lag is just another term for Ether channel. But in the context of wireless LAN controllers, we always use the term lag. And also note that WLCs only support static lag, no PAGP or LACP. So when we configure the switch's interfaces to form the lag, we will use the command channel group 1 mode on, not mode active or mode desirable. You don't have to connect the WLC to the switch using a lag, but it's a good idea to provide additional throughput and redundancy. I will use 3 VLANs, 3 subnets in this network. VLAN 10 is the management VLAN. Its subnet will be 192.168.1.0/24. VLAN 100 will be called internal. Its subnet will be 10.0.0.0/24. And VLAN 200 will be called guest. Its subnet will be 10.1.0.0/24. Note that only VLAN 100 and VLAN 200 will be mapped to a wireless LAN and advertised by the APs. VLAN 10 will just be used for connecting to the network devices, the WLC, switch, and APs, and managing them, for example via their CLI with an SSH connection. VLAN 100 will be mapped to an SSID, internal, which the APs will advertise and clients can connect to. Same for VLAN 200. It will be mapped to an SSID called guest and advertised by the APs. Devices will be able to associate with that SSID too. Now in this video, I won't be doing any advanced policies to control traffic, but in a real deployment, you could limit the guest SSID to internet access only, whereas clients associated with the internal SSID could access all internal company resources, for example. The switch will have an SVI in each VLAN, the .1 address of each subnet. And the WLC will have an IP address in each VLAN too, the .100 of each subnet. The APs will need an IP address in the management VLAN so they can communicate with the WLC, but they will get their IP addresses via DHCP. So where's the DHCP server? The WLC could be the server, but I'll configure the switch as both a DHCP server and an NTP server for this network. I want to remind you that since we're using a WLC, a split MAC deployment, the switch's interfaces connecting to the APs are access ports. Only the WLC needs to connect via a trunk port with all of the necessary VLANs. However, the APs will form CAPWAP tunnels to the WLC. So let's say this client associated with the internal WLAN wants to communicate with its default gateway, which is switch 1's VLAN 100 SVI. The traffic passes through the CAPWAP tunnel to the WLC. On the WLC, the internal WLAN is mapped to VLAN 100, so it will forward the traffic in VLAN 100 to switch 1. Switch 1 then sends it back via the same path. What if the client associated with the internal WLAN wants to send traffic to the client associated with the guest WLAN? It will send the traffic to its default gateway, switch 1, following the same path as before. Switch 1 routes it to VLAN 200 and sends it to the WLC, which will send it to the destination client via the CAPWAP tunnel and the AP. So that's just a quick review of how traffic travels in a split MAC deployment like this. So let's finally start our configurations. First, switch 1. All of these configurations will be reviewed for you, so let's just quickly take a look at them. Here's the first half of the configurations. First, I created the 3 VLANs, 10, 100, and 200, and gave them appropriate names. Then I configured Fast Ethernet 0/6, 7, and 8 as access ports in VLAN 10. F0, 7, and 8 connect to the APs, so why do you think I configured F06 too? It's because I will later connect my PC to F06 to gain access to WLC1's GUI. A device's CLI, command line interface, can be accessed via the console port, or connected to over the network using Telnet or SSH. However, the GUI, graphical user interface, cannot be accessed via the console port. You must connect over the network using HTTP or HTTPS. I'll show you how to do that when I move on to configure the WLC. Anyway, I then configured switch 1's F01 and F02 as a static lag, static ether channel. Remember that WLCs only support static lag, no PAGP or LACP. So you must use the command channel group 1 mode on, not mode desirable or mode active. And finally, I configured the port channel interface as a trunk, and allowed VLANs 10, 100, and 200. And here's the second half of the configurations. I configured an SVI for each VLAN. These will be used as the default gateway for their subnets. I then configured a DHCP pool for each VLAN, and notice that I used the default router command and specified switch 1's SVI IP addresses as the default gateway for each subnet. The VLAN 10 DHCP pool will be used by the APs to get their IP addresses, which they need to communicate with the WLC. Note that the VLAN 10 pool has an additional command, option 43 IP 192.168.1.100. DHCP option 43 can be used to tell the APs the IP address of their WLC. So when the APs get an IP address from switch 1, it will tell them, your WLC is at IP address 192.168.1.100, and the APs will then try to communicate with the WLC and form their CAPWAP tunnels. Although in this case, it's actually not necessary. The APs and WLC are in the same subnet, the same local VLAN, and APs will send broadcast CAPWAP discovery messages to check if there are any WLCs in the local subnet. The WLC will hear those broadcast messages, so the APs will be able to join the WLC. But just be aware that DHCP option 43 might be necessary if the WLC is located somewhere that it won't be able to hear the broadcast discovery messages from the APs. Remember that one for the exam, DHCP option 43. So that's the VLAN 10 pool. The VLAN 100 and VLAN 200 pools will be used by wireless clients. Switch 1 will assign IP addresses to them using DHCP. Okay, the final command I used on the switch is NTP master. This will make it an NTP server, and I'll later tell the WLC to use switch 1 as its NTP server. Okay, that's all of the configuration needed on switch 1. Now let's finally configure the WLC. I can't connect to its GUI yet. First, I need to connect to its console port and do some basic setup in the CLI. So let's take a look at that. When the WLC first boots up, you will be greeted with a configuration wizard. So you don't actually need to know any CLI commands for the WLC to do this basic setup. The wizard will walk you through it. First, it asks me if I would like to terminate auto install. Auto install can be used to automatically download the WLC's configuration from a TFTP server. I won't do that, so I press enter to skip it. Note that the value in the square brackets, yes in this case, is the default. You don't have to type yes. If you just hit enter, it will assume yes. Then I enter the system name, the host name of WLC1, as well as a username and password that I will use later to log into the device. It then asks me if I want to enable link aggregation, LAG. Notice that there are two options in square brackets, yes and no. However, no is in uppercase letters, so it is the default. If I just hit enter, the device will assume I mean no, I don't want to enable lag. However, in this case, I will be using a lag to connect to the switch, so I selected yes. Then I enter some values for the management interface. Note that this isn't a physical interface, a physical port. It's a virtual interface in the WLC. I gave it an IP of 192.168.1.100, a /24 netmask, specified switch 1's IP address of .1 as the default gateway, gave it a VLAN ID of 10, and again specified switch 1's IP address of .1 as the DHCP server. Let's continue with the WLC's basic setup. This is still part of the configuration wizard, so I'm answering questions instead of actually inputting commands in the CLI. These three options at the top are a bit beyond what you need to know for the CCNA, but let me briefly explain them. The virtual gateway IP is an IP address used when the WLC is communicating directly with wireless clients, such as when relaying DHCP requests. The multicast IP address is used when forwarding traffic to its APs. Note that I selected an IP address in the class D range, which is reserved for multicast addresses. And the mobility/RF group name is used when you have multiple WLCs and you want them to work together. I doubt you'll be asked about these on the CCNA exam. Next in the setup, it asks us to configure a wireless LAN, starting with the SSID. I'll show you how to do this in the GUI soon, but first it requires us to make one in this configuration wizard. I use the SSID internal, and then I accept the default settings for the next question about DHCP bridging mode, leaving it disabled. For wireless clients' DHCP requests to reach the DHCP server, switch 1, they must pass through WLC1 first. If DHCP bridging mode is enabled, the WLC becomes totally transparent to the clients. It will appear as if they are communicating directly to the server. But that's not necessary here, so I'll leave it disabled. I also accept the default for the next setting, allow static IP addresses. This means that clients are allowed to use static IP addresses if they prefer. They don't have to use DHCP. And finally, I choose not to configure a radius server now, and it gives me a warning. The default WLAN security policy requires a radius server. We will change the WLAN security policy to use a pre-shared key, so we don't need to configure a radius server. Next, I have to enter a country code, or a list of country codes, and I entered FR for France. Why did I select France? This is actually very important, and was a problem for me when getting this lab set up. Because I live in Japan, I originally entered JP here, but then my APs weren't able to join with the WLC. Here is the reason for that. Look at the model name of this AP here. Specifically, this E in the model name. This E indicates the regulatory domain of the device, E meaning Europe. If the regulatory domain of the country specified in the WLC configuration doesn't match the regulatory domain of the AP won't be able to join the WLC. You can check the regulatory domain of each country here. In Canada or the US, for example, A is used instead of E. So because my APs are E, I configured a country in Europe on my WLC. I doubt that you have to know this for the CCNA exam, but if you have your own wireless lab with secondhand devices, you should be aware of this, or you might run into problems. Okay, here's the final section of the initial WLC setup. I choose to enable 802.11b, A, and G, as well as Auto RF, which allows the WLC to automatically select which channels to use and how much transmit power to use. This is much better than doing everything manually. I then configure some NTP settings so my WLC has the correct time. Finally, I save the settings and the device resets. That's all for the WLC initial setup. So now that the WLC's initial setup is complete, it has an IP address in the management VLAN, VLAN 10. So instead of connecting my PC to the WLC's console port and using the CLI, I will connect my PC to the switch. Remember, I configured switch 1's F06 interface in VLAN 10, the management VLAN. Now I will be able to use HTTP or HTTPS to access the WLC's GUI in a web browser. So I enter WLC1's IP address, 192.168.1.100 in a web browser. However, I get a warning that my connection is not private. The error is certificate authority invalid. This just means my PC doesn't trust the certificate on my WLC, but that's not an issue. Next, I clicked on Advanced here. And now I get the option to proceed to 192.168.1.100. If your browser gives you a warning like this when visiting a website, you should be careful. But I know that I'm just connecting to WLC1 on my local network, so there's no issue here. And here is the login screen for the Cisco WLC. So I click on the Login button. And then I enter the admin username and password I created in the initial setup earlier. And here is the dashboard for the WLC. Let me point out a few things. Notice that it shows which interfaces are up, the green ones, and which are down, the red ones. Those two green interfaces are forming a lag and are connected to the switch. Here there is a summary of some information about the controller, such as its management IP, system name, uptime, temperature, CPU and memory usage, etc. And here is a summary of the access points that have joined the WLC. Note that both of my APs have already joined. Okay, now let's actually do some configurations on the WLC. First, I'll go to the Controller tab up top here. From the Controller tab, I clicked on Interfaces. And here, you can see the WLC's interfaces. Note that these are not physical ports, but logical or virtual interfaces in the WLC. In most contexts, we can use the terms port and interface interchangeably. However, in the context of WLCs, port means physical port, and interface means logical interface within the device. Before configuring the interfaces, let me briefly explain the ports and interfaces of a WLC. Again, WLC ports are the physical interfaces that cables connect to, and interfaces are the logical interfaces within the WLC, like SVIs on a switch. WLCs have a few different kinds of ports. Let me introduce them. The service port is a dedicated management port. It is used for out-of-band management. That means keeping management traffic totally separate from regular data traffic, not using the same physical interface. My WLC doesn't have a dedicated service port, so the management traffic will use the same physical ports as the regular data traffic. Note that the service port must connect to a switch access port, because it only supports one VLAN. Also, this port can be used to connect to the device while it is booting up, perform system recovery, and other system management tasks like that. Next are distribution system ports. These are the standard network interfaces that connect to the distribution system. Remember, that's the 802.11 term for the wired network. And these are the interfaces that are used for regular data traffic to and from the wireless clients. Note that these ports usually connect to switch trunk ports, and if multiple distribution ports are used, they can form a lag, as I did in my network. Then there is the console port, which can be either RJ45 or USB, or perhaps the WLC has both. And there might also be a redundancy port, which can be used to connect to another WLC to form a high availability HA pair. This means you have redundant WLCs, so if one fails, the other one can continue to support the network. My WLC is a bit old, so it just has an RJ45 console port and 4 distribution system ports. These aren't ports, but it has a reset button and some status LEDs on the front as well. To show you the other kinds of ports, let's look at a more modern WLC from Cisco. So here is a pair of WLCs. Let's go through each of these numbers, from 1 to 9. Number 1 is the service port. Again, this can be used for out-of-band management, to keep the management traffic physically separate from the data traffic. Number 2 is an RJ45 console port, and number 3 is a USB console port. Then there is another USB port. This isn't a network port, it's just a regular USB port used to transfer files to the WLC, for example, a new OS version to update the software. Next, number 5 is a distribution system port, and it supports multi-gigabit speeds, beyond 1 gig. And then 4 more distribution system ports. These ones are regular 1 gig ports. Number 7 isn't a port, it's a reset button, like on my WLC. And there are status LEDs too, indicating the status of the device. Those are number 8 on this image. And finally, number 9 is the redundancy port. You could connect these two WLCs by their redundancy ports, and they would form a redundant pair. Okay, those are the different kinds of physical WLC ports. WLCs have a few different kinds of interfaces too. The management interface is used for so-called management traffic, meaning communications used to manage devices, such as Telnet or SSH connections to the CLI, HTTP or HTTPS connections to the GUI, radius authentication traffic, NTP and syslog traffic, etc. Remember that, to connect to the GUI of the WLC, I accessed the management IP address of 192.168.1.100. CAPWAP tunnels between the APs and WLC are also formed to and from this interface. Next, there also might be a redundancy management interface. When two WLCs are connected by their redundancy ports, one WLC becomes active and the other becomes standby. To manage the active WLC, you can connect to the management interface. But to manage the standby WLC, you can use the redundancy management interface. Next, there is the virtual interface. Remember I had to configure this IP address when initially setting up the WLC? It's used when communicating with wireless clients to relay DHCP requests, perform client web authentication if necessary, etc. Next, there is a service port interface. If the WLC's service port is used, this interface is bound to it and used for out-of-band management instead of the regular management interface. And finally, there are dynamic interfaces. These are used to map a wireless LAN to a VLAN. For example, traffic from the internal wireless LAN will be sent to the wired network from the WLC's internal dynamic interface. So let's go back to the GUI and configure a couple dynamic interfaces to be used for our wireless LANs. Here's the Interfaces menu again. I'll click New to create a new interface. First, I'll make the interface for the internal WLAN, and notice I'm mapping it to VLAN 100. Then I'll click on Apply. I am then brought to this screen where I can enter more details. The VLAN ID was already set to 100 from the previous screen, but I entered the IP address, netmask, gateway, and DHCP server address. That's all I need to enter here, so I clicked on Apply. By the way, feel free to pause the video at any point if you want to take a look at the different settings available in any of these menus. So, now the dynamic interface called internal has been created. I will map this interface to the internal WLAN later, but now I have to create one more interface. That is the guest interface, so I click on New again. And then at this screen, I specify a name of guest, and I map it to VLAN 200, since that will be used for the guest WLAN and VLAN. Then I click Apply. Again at this screen, I enter the IP information needed for the guest interface, the IP address, netmask, gateway, and DHCP server address, and then click Apply to finish creating this interface. Okay, now the WLC has all of the interfaces it needs. Finally, let's go to configuring some WLANs. To do that, just click on the WLAN tab here at the top of the GUI. So here's the WLANs tab. Note that one WLAN, internal, already exists. That is because I made it during the initial setup in the CLI. However, I still have to make some changes to this one. For example, look at the security policies column on the right. It is configured to use 802.1x authentication, so WPA Enterprise mode. But for the CCNA, we have to configure pre-shared key authentication, in other words, WPA Personal mode. So if I click on the WLAN ID, the number 1 on the left, I am able to edit this WLAN. The profile name is internal. It's a WLAN, the SSID is internal, and it's enabled. That all looks good. Here's the security policy. As I said before, I'll have to change that, but it's done on the Security tab, not here. Now here's a problem. Currently the internal WLAN is mapped to the management interface. That's not correct. We should map it to the internal dynamic interface. So that's what I did. I selected the internal interface here. Now it's time to go to the Security tab and change that security policy to use a PSK instead of 802.1x. Here's the Security tab. First up, notice what's called the Layer 2 Security setting. This is where we can select things like WEP, 802.1x, different versions of WPA, etc. Currently it's WPA plus WPA2, which is what we should select for the CCNA. For your reference, here are the Layer 2 security options available on my WLC. Note that the newer WPA3 isn't supported, but that's fine. We're supposed to use WPA2 for the CCNA. Next, look down here at Authentication Key Management. 802.1x is selected. This is what we want to change. It should be PSK. So, I scrolled down a bit, deselected 802.1x, and selected PSK, pre-shared key instead. Notice that the PSK can then be specified either in ASCII or in hex. Hex means hexadecimal, the same number system we learned for MAC addresses and IPv6 addresses. ASCII means American Standard Code for Information Interchange. Basically, it means you can enter your password using regular letters, numbers, and symbols. So, I selected ASCII, entered a short password, clicked on Apply, and then I got an error message, stating that the PSK in ASCII format should be at least 8 characters in length. This is to make sure the password is secure, not easy to crack. So this time I entered a longer password. Clicked on Apply, and it worked. We won't configure any Layer 3 security methods, but for your reference, I checked the Layer 3 tab, and you can see that my WLC supports something called Web Policy. If I select Web Policy, various options appear, such as Web Authentication and Pass-Through. Web Authentication means that, after wireless clients get an IP address and try to access a web page, they will have to enter a username and password to authenticate. Web Pass-Through is similar, but no username or password are required. Instead, a warning or statement is displayed, and the client just has to agree to gain access to the internet. In either of these examples, the Layer 2 authentication can just be open. This is common for public Wi-Fi, for example at a cafe. Note that the conditional and splash page web redirect options are similar, but additionally require 802.1x Layer 2 authentication. Anyway, as I said before, we won't configure any of these, so let's move on without enabling web policy. There is also a AAA servers tab, but since we are using PSK authentication only, there's no need to set up anything like a Radius server. So let's go to the QoS tab now. Here's the QoS tab. The only thing you need to be aware of here is the QoS setting, which is Silver, best effort by default. Here are the options available. This is how you can control what quality of service is provided to the wireless clients. Platinum should be used for voice, for example, Wi-Fi IP phones. Gold should be used for video traffic. Silver is the default, and Bronze is given the lowest priority for what's called background traffic. Anyway, in this case, I'll just leave it at Silver. But for the exam, definitely know these 4 QoS settings: Platinum, Gold, Silver, and Bronze. Okay, finally, we'll take a look at the Advanced tab. In this tab, there are lots of different settings. For example, you could configure a maximum number of clients allowed. Currently, it is 0, meaning there is no maximum. Okay, I'll scroll down to see other settings. Here are some additional settings. For example, if you want to enable Flex Connect, you can do it here. But I won't touch these advanced settings, so I will just click on Apply to finish editing this WLAN. Okay, the internal WLAN is done. Next, I'll click on Go here to create a new WLAN, the guest WLAN. Okay, since we're creating a new WLAN this time, we have to specify the profile name, SSID, and ID first. The profile name is used to identify this WLAN in the WLC, and usually you'll just make it the same as the SSID, as I did in this case. Note that the profile name and SSID don't have to be the same though. Then there is the ID, a unique number that identifies the WLAN. The internal WLAN was 1, so I'll make this one too. So I'll click on Apply to move forward. Okay, now we're at that same page. Since we already went through all of the settings for the internal WLAN, I'll go through this quickly. There are 2 things we should change on this general tab. First, the status. The internal WLAN was already enabled, but this new one is not, so we should enable it here. And secondly, we should change the interface to the guest interface we created earlier. Okay, I changed the settings. Now the only other change we have to make is to change the security policy to use a PSK on the Security tab. I've already shown you how to do that, so for the sake of time, let's skip over that. Okay, now we have 2 WLANs, the internal WLAN and the guest WLAN. So let's return to the monitoring dashboard and see if anything is different. Here's the dashboard again. I scroll down a bit, and you can see that we have 0 clients associated with the APs. So let's change that. On my iPhone, you can see that the guest and internal WLANs are visible, so I'll join with a few of my devices. Okay, now you can see that there are 3 clients associated with the APs. To see a list of them, you can click Clients here on the sidebar. Here's that list of clients. It shows their IP addresses, which AP they are associated with, which SSID they are using, etc. Okay, we've looked at a lot in this video, but before we finish up, let's take a quick look at a couple more things. Let's go to the Wireless tab here. The first thing we're shown is a list of the APs that have joined this WLC. You can see their IP addresses, model numbers, MAC addresses, etc. Let's click on an AP name and check the settings. Again, here you can see a lot of information about this specific AP. Look here, AP mode local. You should know what this is. Let's check the other options. These are the operational modes I covered in earlier videos: local, Flex Connect, monitor, rogue detector, etc. This is where you can configure the AP's operational mode, but I'll leave it at the default of local. Okay, next let's look at the Management tab. Here is the Management tab. First, you can see a summary of the management settings. For example, SNMP v1 is disabled, but v2 and v3 are enabled. syslog is currently disabled. HTTP and HTTPS connections are enabled. Telnet connections are disabled. To prove this, I tried to telnet from my PC to the WLC, but the connection failed. Telnet is not a secure protocol, so it's best to leave it disabled. SSH is enabled, and management via wireless is disabled. This means that a wireless client won't be able to connect to the WLC and manage it. Only a device connected to the wired network can. Let's change that setting by clicking on Management via Wireless here. You can change that setting by checking this box here and then clicking Apply. If this is enabled, a wireless client, for example a laptop using Wi-Fi, will be able to connect to the WLC and make configuration changes. Anyway, let's look at one last thing, here on the Security tab. So I clicked on the Security tab, and then Access Control Lists here. Let's configure an ACL to limit the management traffic allowed to access the WLC. There are no ACLs at the moment, so I'll click here to make a new one. First, I named the ACL Management ACL, and left the type as the default IPv4. Then I clicked Apply to move forward. Okay, now the ACL has been created. But as you can see here, it still has no rules. So I'll click here to add a new rule and specify what traffic can access the WLC. This is where you specify things like the sequence number, source and destination IP, protocol, DSCP marking, direction, etc. So I specified a sequence number, source and destination, and then clicked on Apply to make the rule. I followed that process again to make 2 more rules, and now there are 3 rules in this ACL. Don't worry about the exact contents of these rules I'm making. I just want to show how to make an ACL. So now that the ACL is made, let's apply this ACL so that it limits access to manage the WLC. To do so, click here, CPU Access Control Lists. To apply the ACL, check Enable CPU ACL here, and select the appropriate ACL from the list. Then, simply click on Apply, and that's all. So, CPU ACLs are used to limit access to the CPU of the WLC. This limits which devices will be able to connect to the WLC via Telnet or SSH, HTTP or HTTPS, retrieve SNMP information from the WLC, etc. This doesn't affect traffic passing through the WLC, only traffic destined directly for the WLC. Okay, there are so many more things I could show you in the WLC, but this video is getting quite long, and we've covered what we need to for the CCNA. To practice for the CCNA, you can just use the WLC and APs in Packet Tracer. That's no problem at all. But if you're interested in really exploring what you can do with a WLC, you can probably get some secondhand hardware for cheap like I did, and set up your own home lab. But again, that's not necessary for CCNA studies. Before moving on to the quiz, let's review what we learned in today's video. First, I introduced the network topology we used for today's video. Then I showed the configurations I did on the switch, such as IP addresses, interface settings, and DHCP pools. Then I showed the basic WLC setup, which is required to access the GUI. Then I showed how to configure WLC interfaces. Remember the difference between physical ports and logical interfaces. Up to now, I've always used the terms port and interface interchangeably, but when talking about WLCs, you should be specific. I then showed how to configure WLANs on a WLC. We configured the internal WLAN and the guest WLAN. And finally, we looked at some additional features, such as how to configure a CPU ACL to limit management traffic to the WLC. Make sure to watch until the end of the video for a bonus practice question from Boson Software's XSIM for CCNA, the best practice exams for the CCNA. Okay, let's go to quiz question 1. Which WLC port can be used to form an HA pair with another WLC? Pause the video now to select the best answer. Okay, the answer is redundancy port. The redundancy port in this image is number 9. It can be used to connect the two WLCs together to form a high availability HA pair. One WLC will be active and the other will be standby, ready to take over if the active one fails. Okay, let's go to question 2. Which WLC interface type maps a WLAN to a VLAN? Pause the video now to select the best answer. Okay, the answer is A, dynamic interface. Dynamic interfaces are used to send traffic between wireless clients and VLANs on the wired network. In this video, for example, we created two dynamic interfaces, internal and guest, and used them to map the internal and guest WLANs to VLANs 100 and 200. Okay, let's go to question 3. Which of the following is a type of layer 3 authentication? Pause the video now to select the best answer. The answer is D, web authentication. Web authentication can be configured under the Layer 3 Security tab of a WLAN. It requires users to authenticate with a username and password before being permitted to access the internet. Okay, let's go to question 4. Which WLC QoS setting should be used for video traffic? Pause the video now to select the best answer. Okay, the answer is B, gold. Here are those QoS options again. Silver, best effort, is the default, but gold is recommended for video traffic. Okay, let's go to question 5. Which WLC port type can form a lag to pass standard data traffic? Pause the video now to select the best answer. Okay, the answer is B, distribution system port. These ports are the standard network ports that the WLC uses to pass data traffic to and from wireless clients. Okay, that's all for the quiz. Now let's take a look at a bonus question from Boson Software's XSIM for CCNA. Okay, here's today's Boson XSIM practice question. You are configuring a normal WLAN by using the WLC GUI. You want to configure the WLAN with the SSID of My Company LAN. You click Create New on the WLANs page. Which action are you most likely to perform first? Select the best answer. Okay, there are 4 options. Pause the video now to select the best answer. Okay, let's check. So this question is actually quite challenging, I think. Not because it's complex, it isn't very complex, but just because it requires you to be very familiar with what this screen, what this WLAN creation screen actually looks like. So if you remember correctly, at the top, you select a WLAN type. Now, I didn't actually do this in the video because the default type is standard, or normal WLAN. Now, there is another type called guest LAN, but actually my WLC doesn't support the guest LAN. So I just left it at normal WLAN, even for my guest WLAN. I just changed the name to guest, but the type was still normal WLAN. Anyway, so there are multiple types. So at the top there is the type, then under that the second selection is the profile name, and then under that is the SSID, and then finally at the bottom of the menu is the ID number of the WLAN. So the first one at the top is the type. So would you do that action first to create this WLAN? No, you wouldn't, because the type of WLAN you are trying to create is normal. So you wouldn't select guest LAN from the type drop-down list box. So A is incorrect. So the option under that is the profile name. So I would say you are most likely to perform this action first, D. Assign a profile name of up to 32 characters in the profile name field. Okay, click on Show Answer, and that is correct. So this is Boson's explanation. I recommend pausing the video to read this. Okay, and there's some more down here at the bottom. And there are some references to the official cert guide for the CCNA, as well as some documentation online from Cisco. Okay, so that was a quick look at Boson Software's XSIM for the CCNA. These are the best practice exams for the CCNA, and I highly recommend them. If you want to get XSIM, please follow the link in the video description. There are supplementary materials for this video. There is a flashcard deck to use with the software Anki. There will also be a Packet Tracer practice lab, so you can get hands-on practice configuring a Cisco wireless LAN controller. That will be in the next video. To get the supplementary materials for this course, sign up at the link in the top of the video description. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to Amiens, Gina, Valeri, Marco, Tanvir, Vitaus, Benji, Kwa, Ricardo, Mason, Mayor, Petrocius, Dragos, Gerard, Tom, Tebogo, Pavel, Abraham, Njoku, Suki, Kenneth, Seamus, Marcel, Kone, Echo, Gustavo, Prakash, Nasir, Erlison, Ed, John, Funny Dart, Velva Jacob, Boson Software, Devin, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, October 17th, 2021. If you signed up recently and your name isn't on here, don't worry, you'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.